Hello everyone. So kule video yanamhlanje sizoqhubeka la sigcine khona ngama nge-calculus. Sigcine sibheka i definition ye-derivative of a function, right? So we defined the derivative of a function as the limit as h goes to 0 of f of x plus h minus f of x divided by h, and then we also did a few examples applying the definition, right? So if they say derived from first principles, we know what we're gonna apply this definition in a limit. Okay, so today last soqhubeka khona sizobheka ama rules of differentiation, right? Sizobheka ama rules of differentiation, right? Because we can't use the first principles all the time. Sometimes it's easier if you use the rules straight away, and then they say if the question doesn't say you need to differentiate from first principles, it is easy to use the rules, right? So here are the rules that we have. If f of x is equals to a constant b, then the derivative of that function is 0, right? If f of x is equals to b, then f derivative x or f prime x is equals to 0, right? If f of x is equals to x to the power n, then f prime x is equals to n times x to the power n minus 1, right? And then this one says the derivative of a sum is equals to the sum of the derivatives, or the derivative of a difference is equals to the difference of the derivatives. And then this one says the derivative of a constant times a function is equals to a constant times the derivative of the function. The constant there is k, right? And then they also have some examples here on the sides. Like if we look at the first rule, we're saying if f of x is equals to a constant, then the derivative is 0, right? Here is an example. If h of x is equals to 12, then f prime x is equals to 0, because this function is equals to a constant, right? Then the derivative of a constant is always 0, and then if f of x is equals to x to the power 5, then k prime x is equals to 5 times x to the power 4. Lapha apply rule number 2, which is x to the power n being our function, and then the derivative will be n times x to the power n minus 1, right? And then this example here, we are applying the third rule, which says the derivative of a sum is equals to the sum of the derivatives, right? And then this one we this one here, we are applying the last rule, which says the derivative of a constant times a function is equals to the derivative of a constant times a function is equals to the constant times the derivative of the function, right? So before you use the differentiation rules, you might need to simplify or change the format of the expressions, right? Like in the case of brackets, if you are given something like this, you'll need to expand the brackets, and then have an expression like this, which will make it easier for you to apply the rules, right? Also, if you are given something in a square root format, you need to write it in an exponent format so that you can apply the rules, right? So yeah, I think that's all there is to differentiation and derivatives. Now let us look at the questions that I sent and said you guys have to do, right? We have question 8, which says differentiate this function from first principles. Okay, so we're just gonna copy question 8 right? So we have this question which says differentiate this function from first principles. If they say from first principles, then you know what you have to use the definition of a derivative, which says that the derivative of a function f of x is equals to the limit as h goes to 0 of f of x plus h minus f of x divided by h, right? So let us go ahead and apply that definition here. Okay, so here we have to differentiate g of x equals to x squared minus 5 from first principles, right? Then we know that we need to use the definition of the derivative, which says that the derivative of a function is equals to the limit as h goes to 0 of g of x plus h minus g of x all divided by h, right? And then now the first thing we need to do is to find g of x plus h, right? G of x plus h is equals to, wherever we see x in our function, we put x plus h squared minus 5, which will be let me write it here. It will be x squared plus 2xh plus h squared minus 5, right? And then now we need to calculate the numerator, which is g of x plus h minus g of x, right? We have g of x plus h, which is this expression. So we'll have x squared plus 2x plus h plus 2xh plus h squared minus 5. And then we have to minus our function. So we're going to have minus x squared plus 5, right? And then we collect all the like terms. This and that will cancel. This and that will cancel. And we will remain with 2xh plus h squared, right? And then now we can calculate the entire fraction and say g of x plus h minus g of x divided by h will be equals to, we can factorize h out, 2x plus h divided by h, right? Then that h and that h will cancel, so we'll have 2x plus h, right? Therefore g prime x will be equals to the limit of 2x plus h, right? And then now from this step, wherever we see h, we put 0, and then our final answer will be 2x, right? That was an easy 5 marks. Let's go on to question 8.2. Okay, 8.2. Right, now here they say evaluate dy dx if y is equals to this expression. Here we'll have to apply the rules of the differentiation, and then in order for us to apply the rules, we have to first simplify this expression, right? So we need to simplify y. So y will be equals to x to the power 6 divided by 2 plus 4 times x to the power 1 over 2. Right? Remember that the square root of x is the same as x to the power 1 over 2. Right? So now, having our y as this expression, we can go ahead and apply the rules of differentiation. Right? So dy dx will be equals to, here I will apply the rule which says the derivative of a sum is equal to the sum of the derivatives. So I will have to calculate the derivative of this term and the derivative of that term, right? So now calculating the derivative of this, I'll have 6 over 2 x to the power 5, right? So there I'm applying this rule which says if I have x to the power n, then my derivative will be n times x to the power n minus 1, right? So here I am my n is 6, so I have 6 times x to the power 6 minus 1, which gives me 6 times x to the power 5, right? Same thing here. Here my n is 1 over 2, so I'll have 1 over 2 times x to the power 1 over 2 minus 1, right? So I'll have 4 over 2 x times 1 over 2 minus 1 will be minus 1 over 2, okay? And then this will be 3x to the power 5 plus 2x to the power minus 1 over 2, and we can simplify further and say this is 3x to the power 5 plus 2 to the power over the square root of x, right? Which is that part there. And easy 3 marks. You simply apply the rules of differentiation, right? Now let us go on to the last question. Okay, question 8.3. So 8.3 says a function g of x equals to a to the power ax squared plus b over x has a minimum value at x equals to 4. The function value at x equals to 4 is 96. Calculate the values of a and b, right? So here you are given a function and some information, right? The information that we are given is that the function has a minimum at x equals to 4. What does it mean to that the function has a minimum at x equals to 4? Notice with this function is a no, it's not a parabola. I was supposed to say it's a parabola. Okay, I don't exactly know how it looks like, but then it does say it has a minimum value at x equals to 4, right? It means at x equals to 4 the function is maybe changing direction. It's first decreasing and then it's increasing, right? So the gradient of this function at x equals to 4 has to be 0, right? Because if it will be sort of like have a horizontal tangent at x equals to 4, right? So the point of giving you this information is to tell you that at x equals to 4 the function has a 0 gradient, which means that g prime of 4 is equals to 0, right? Now that's some information which we are given when we are also told at x equals to 4 the function is equals to 96. So g of 4 is equals to 96, right? Don't confuse these two, they are not the same. Here I have g prime 4 equals to 0, which is the gradient of the function at x equals to 4. And here I have g of 4, which is equals to 96, which is the value of the function at x equals to 4. They are two different things, right? So now with this given information we can go ahead and calculate the values of a and b. So we know what our function is g of x ax squared plus b over x, right? And then if we calculate g prime x, we will get that it will be, now I'm applying the rules of differentiation, right? So if you don't know how to apply the rules of differentiation or don't know how to differentiate, you will have difficulties in answering this question, right? So make sure you know how to apply the rules of differentiation, right? So here I'm gonna apply the rules of differentiation. I'll have g prime x will be equals to 2a x to the power 1, which is 2 minus 1 there, which is just 2ax, and then plus b. Okay. In order to apply the rules of differentiation, we have to rewrite this function as ax squared plus b x to the power minus 1, right? So now I can apply the rules of differentiation on this expression here, right? The first one is still 2ax, and then the second term, when I differentiate it, I'll have minus b x to the power minus 2, right? I'm simply applying the rule which says if f of x is this, then if f of x is this, then f prime x will be equals to n to the power x, sorry, it will be equals to n times x to the power n minus 1, right? I'm applying this rule. Okay, so so here I'll have, simplifying this, I'll have g of x to be equals to 2ax minus b over x squared. Okay, and then now I can go ahead and use the given information. So the given information, I'll just substitute g of 4, I know what it's 96, and then I know what if I substitute 4 wherever I see x, I'll have a where I see 4 I put x plus b over 4 equals to 96, and then I will simplify. I'll have 16a plus b over 4 is equals to 96, right? I'll call this my equation 1, right? And then here I know what g prime at 4 is equals to 0, because I'm told what the function has a minimum value at x equals to 4. That's why I know what the gradient at 4 is 0. Okay, so g prime 4 is equals to 0. G prime is equals to this expression. So wherever I see x in this expression, I'll put 4, right? I'll have 2a and then 4 there and then 4 there. Okay, so I'll have 2a times 4 minus b over 4 squared equals to 0, which will be 16a minus b over 16 is equals to 0, right? And then I'll go ahead and make b the subject of the formula. I'll have 16a is equals to b over 16, and then b will be, if we cross multiply, sorry, this is 2 times 4, it's 8, not 16, right? If I cross multiply, I'll have 8 times 16, which will give me 128a, right? And then I'll substitute this into my equation 1, right? This will be equation 2. So I'll say sub equation 2 into equation 1. Okay, and then I'll get, wherever I see b, I put 128a, right? 16a plus, wherever I see b, I put 128a. 128a divided by 4 is equals to 96, right? And then now I can solve for a. So here I will have 16a plus 128 divided by 4 is 32a equals to 696, and then 16 plus 32 will be 48a equals to 96, and then if we divide by 48 both sides, we'll get that a is equals to 2, right? And then we take this value of a and we substitute it back to equation 2, right? And then we'll have that b is equals to 128 times 2, which is the value of a. We'll have b to be 256. That will be our value of b. And then we are done with this question. Okay, so yeah, that's all there is to calculus. So you just have to know how to differentiate from first principles and differentiate by using the rules. Okay, so if there's anything that you don't understand, feel free to ask. I'll be happy to explain.